Hi, my name is Brandon Majors, and this is my practice presentation for the science conference. So, I attend the CTC program over at the CCBC College for Machine Tool Technology. I had wanted to make a long-term while I was doing something over there, since no one had ever done a industrial arts long-term. So I wanted to create a long-term using an automatic mill that I have right here, and I wanted to test how does the cutting speed affect the smoothness of a metal cut. So first I started by making a claim, which was that I think as I get higher in speed and as I move faster in RPM, the cut of 15 thousandths of an inch will have the smoothest cut on the part. I had thought that only because my teacher had always taught us that way. So first I had wanted to set up. So I had taken a scrap piece of metal that I had used, and I had made it into a hexagon on it. I had drawn with just Sharpie, and I had used a roller so then each side was the same whenever I go to cut across. And I did this just because I wanted to use 6 different sides, since I was using 6 different speeds to vary it. Now right here is a picture of the vise and the jaws on the machine that will actually hold the piece. So whenever my cutter comes down to it, I had to use what we call a parallel. Usually we have those standing straight up and down, and then you can place your part on top of it. But since my part was big enough, I just wanted the tip of it to stick outside of the vise, just like right outside of here, just then I was getting a flat cut. And so the cutter I was using is what we call a fly cutter. And so basically what it does is it just rotates in a circle and cuts and just pushes all the metal pieces off to the side. So basically what I had to do first, I had used, which this brush is here, only to wipe away the chips, and also I had to use WD-40 is what we use for our cutting oil. So I had used that first just to make everything the same, and just so then it was all smooth. I had ran it at about 1500 RPM or so, and I had just made each side flat. And I had measured from the center of the hole, which was a perfect circle. I had measured to the outside, which I had gotten exactly 0.376 of an inch. Just then each side was the same, coming out away from the hole, just in case if that had any effect. I wanted to make sure it wouldn't. So whenever I was determining the cut, since I had already had all of the sides, I decided why not, since it has 2 different speeds on the mill, I was going to use the slow range speeds and the fast range speeds. And so basically what I did is on my final cuts and everything, I just labeled each side. So I had 1, 2, and 3 as going to be on my low range for my speed. And then I had 1 decimal, 2 decimal, 3 decimal. So it's going to be on the high range. So basically to switch it, all I'd have to do is just move this lever from low to high. And I chose these numbers because these numbers are pretty stationary. We use those a lot while we're cutting, just to make nice smooth cuts or nice rough cuts, depending on what we're trying to do, depending on how we want to get to the point. So whenever I chose 60, 180, and 300, on the opposite side, since I could see the high range speeds as well, these were the speeds that matched up exactly with it. And so whenever I was doing this, I wanted to just take off 15 thousandths of an inch, and so that's what this was. But whenever I went to go to the other side, since it was going to be sitting on this flat part, say after I'd already cut 2, and I went to cut the 2 decimal point, since I would have to cut this side, I had to change this to for 30 thousandths of an inch, only because I had already taken off 15, so I had to double it just then I was cutting off the same thing, or else I wouldn't be cutting off anything. So right here is my first video. This is whenever I didn't use any kind of cutting oil because I wanted it to just be as raw as possible. But this is the fly cutter, and it really demonstrates and shows how the cutter actually works and how it just goes right across the piece, just pushing every piece of metal off to the side. But I did that the whole way down. And then this is whenever I rose it up to 180. And as you can see, our chips in the back are getting, they're still pretty long and pretty thick chips. And as you can kind of see, there's like, I don't want to say it's warping, but you can definitely see like the lines from like the heat and different things and the scratch marks going across. And then this is at 300 RPM. So as you can see, this was our 180, if you can also see right there. But now this is going to be our 300 RPM. Now as you can see, the chips are starting to get a little bit smaller and a little bit more round, and they're just being thrown off a lot farther. They're not just being pushed off, they're being thrown as well. And so now whenever I put it into the high range and I got up to 1600 RPM, now as you can see, the chips are very, very tiny and they are flying off, and there are a lot more chips. But I also noticed right here, as you can see, the piece was actually starting to bubble over almost, and it was starting to just warp right there at the end. So instead of it just being flung off, it was actually just pushing the metal all the way down this side. So over here is all being cut off, but this side was just being pushed the whole way. And I don't know if that really had an effect or not. So then I rose it up to 1800 RPM, and now I can really see that it was really starting to come over most of the part as I got to here, and then it was being cut off as it got higher. But the chips were being flown completely off the machine and onto the ground instead of just over here on like the vices. And I did clean off the vices every single time into a Ziploc bag so I could just measure them afterwards. But now at 3000 RPM, I was definitely getting really scared while I was going at this, because we should never be going this high, and I was almost in the danger zone. But as you can see, there are tons of fraying going on almost as the metal is just coming up and just being pushed. And as you can really see, it's just really showing these lines, which is really, it was interesting to me. But just to see this, it was really cool. But the chips are very, very small. So just to test, just so I can actually see which side was the roughest, I had used a surface roughness tester, which is what we use all the time over there. So if we have to send a part in to be measured or whatever, or for a company and different things, you have to use this just to make sure it's in their tolerance. But basically how this thing works is there's a needle that sticks out of the top, and as it comes across the part and then retracts, it is measuring, and that needle goes in and out of each of the grooves, which then can tell you how it is, how rough it actually is. So this is our test for just our 60 RPM going across the top, and as it came back, it was 15.7 units, which wasn't that bad. Now this is for 300 RPM, and it came out to be, I think it was around 16.7, so it's actually getting rougher as it goes. So this is my graph on just the speeds themselves and everything. I just wanted to show two of those just because it's pretty basic as it goes across. But as you can see, whenever I got to my 300, it was at 15, and actually my 180 RPM is actually my smoothest cut out of my low ranges. And as I get over into my higher, my 1600 or my 1060 RPM is actually my smoothest cut. So whenever I did it the second time, I got basically about the same results, so I was pretty comfortable with how everything went. And especially for not using cutting oil or anything, I was really getting scared with how heated up the part was going to get and with how like the chips and everything were going to affect. But while I was doing that, on my second test, I decided to actually use the thermal gun and measure how hot it was going to be getting. So this is my cut on a 60 RPM, and as you can see, it was 78 degrees. And that was extremely hot, I thought. So as I got closer to the cutter, it was super hot, and it got clear up to 80. And then as I got farther away on the spots that had already cut, it was around 70 or so, which was pretty high. And then for my 3000 RPM, while I was actually cutting, I decided to check inside of the hole as well. And I noticed that it was getting extremely hot on the inside, which is making me think that possibly a ton of the heat is going out through the center, which is what is basically causing it not to warp on the top. And I didn't know that, and I didn't think, but now for mostly if I'm ever going to make another part like this again or so, I might drill a small hole, like a tap hole, all the way through the center just to let the heat go out through it, which will make the part a lot stronger and actually make our cuts a lot smoother. But the cutter did remain the same throughout the entire experiment. None of that did change. The cutter was getting hot, but it wasn't hot enough to actually change the shape of it. So these are my chips after my 60 RPM, my 180, and my 300. As you can see, my 60 and my 180 are pretty close and pretty similar to the same. Now my 300 actually got more stringy, so they actually got more, they got really thin, but they also started to really curl a lot more, which is what I noticed whenever I got into my high range. So my 1060 RPM was just really starting to like curl a lot. My 1800 was by far the craziest. They were getting into, like, as like they would go off, they would just curl and then they would break off, and they were coming out in chunks, probably about 4 centimeters or so, which was pretty crazy to me. And then our 3000 RPM, and they were actually so hot that as they were flying off and they were landing, they were actually melting together, and they stayed together on there. So the problems that I did have, I wasn't sure if the cutter have become dull throughout the entire experiment, and that the heat from actually just scraping the metal without oil could have affected it. And I also thought with the hole in the center, I wasn't sure if that was affecting it, definitely by warping the inside of the part or warping the outside of the part. So next time I might just try a completely solid part just to see if that would have a different effect, and see if it would cause more heat on the outside, and see if it would actually change the whole cutter itself. So my results that I found out at the fastest speed was completely wrong. It was not the smoothest cut. It was by far the roughest cut. And so I would definitely, if I'm ever going to be cutting that high at a speed, it has to be something, kind of get it down. It wouldn't be my finishing cut. I definitely would use it to get smooth enough to where then I could slow down the speed and go for a more precision cut and get it a lot smoother. So my second highest speed at 1800 RPM was definitely by far the smoothest. So what I noticed is that the chips and pieces of the material cut off of the part were thrown differently. So some were just being pushed off to the side, and it wasn't really cutting it. It was just forcing it off to the part. And then as I got higher, the parts were just being thrown. Also, the part I was cutting seemed to hold its shape, and so it didn't warp, which was very good for me. If I did this again, I would definitely try using a different cutter, maybe not a rounded cutter, but a sharper cutter with a point on it, just so then it could show the actual scrapes in it, and I could see how that actually affects it, whether it's going slow or not. I would just have to make sure that the tip wouldn't break whenever I went at a super slow speed like 60 RPM. Thank you, and enjoy the conference.